This is Mrs. O'Neill for AP Chemistry, Chapter 1, Section 2, Classifications of Matter. The first thing you should have done was watch Mr. Anderson's video and take notes. This was on molecules and atoms. So these are the notes that I took. He said that all matter is either a mixture, and there's two types of mixtures, homogeneous like salt water, heterogeneous like dirt. He also talked about pure substances, and we're going to talk about those a little bit more in detail. Like now, he said a pure substance is always the same average mass. So if we look at an element like gold, all of the gold atoms that are in this chunk of gold would have the same average mass. Same thing with water. All of those water molecules, H2O, are going to have the same average mass. But now he also compared H2O2. So you notice this is H2O, water. This is H2O2. This is going to be hydrogen peroxide. So this is a different compound, which means it's going to have a different ratio for the average mass. So hopefully you can see the difference here. He talked about element red and a blue element. So these are two different elements. We can have a mixture of those two elements, and we can also have a compound of those two elements. So in a compound, notice they are chemically combined, but in a mixture, they're just all over the place. So we talked about that bar of gold again, and no matter how big or how small that atom of gold is, the average mass of those atoms would be the same. He compared this to something like density, and he said that it's always a ratio, so that's why it's the same all the way through. So then he gave you an analogy using bricks. So a 2.5 gram for one brick is going to give us a 2.5 gram per brick. If we talk about 4 bricks, which would weigh 10 grams, if you do the ratio, again, you're left with 2.5 grams per brick. So notice, depending on how many bricks we have, the mass will increase, but the ratio of the mass to how many bricks would always be the same. Same thing's going to happen for molecules. So if you have H2O, you have 3 grams for every 1 unit. So obviously your mass is going to increase as your units increase, but the mass overall, or the average mass per unit or per compound, is going to be the same. So for different molecules, there's going to be different masses. So he talked about H2O, again, having the 3 gram per unit. But if you talk about H2O2, so notice he gave the same units, okay? So you have 4 units of water versus 4 units of hydrogen peroxide. Your masses are different, which means your average mass for each of those compounds will be different. And that's one way sometimes we can classify an element or a compound, any pure substance. So this is important because in the future you will be expected to decide if what is being asked is a pure substance or a mixture. So for example, when we get to IMFs, which are intermolecular forces, we're going to look at how these pure substances interact with each other. And then we're also going to have a whole chapter on solutions, and again, we're going to need to know how does that salt and water make that mixture. So here's a nice visual for you. We have atoms as an element. We have molecules as an element. Remember the Cliff H. Braun. We're going to talk about that in a second. And then you have molecules of a compound and mixtures of elements and compounds all together. So hopefully that's a good visual there for you. So onto your notes packet, you should have that out. And again, I'm going to remind you that when it gets to the notes, you might want to pause the video, fill in the blanks, and then come back and listen to my words. So your objectives in this section is to identify ways to classify matter, distinguish between those pure substances and mixtures, and distinguish also between elements and compounds. So again, back to those 3 states of matter, the 3 main ones that are going to be important are the gas, or sometimes we call it vapor, so we want to make sure that we remember that. Sometimes we call it vapor, liquid, and solid. So here's some visuals for you. An example of water. Here's a solid, here's a liquid water, and here would be that gas vapor stuff. So I just kind of have some cute things there. But we want to know or understand this on the molecular level. What are those molecules look like in this case, a gas, liquid, or solid? So that's going to be real important to get that visual in your head. So pure substances can be elements or compounds, not mixtures, okay, not mixtures. But we want to talk about how those elements can also be diatomic molecules. So remember Cliff H. Braun, that's how I remember it. These diatomic molecules are also considered elements. So if we use the periodic table for location, which I thought this was neat, since there's 7 of them, 1, 2, 3, 4, 5, 6, 7. Here's 1, and here's 1, 2, 3, 4, 5, 6. That makes 7, and it looks like a 7. So I thought that was pretty neat. And remember that hydrogen is always that oddball out. There's also elements that don't exist by themselves either, like phosphorus and sulfur. They exist as what they call a polyatomic molecule. So phosphorus always exists as P4, even though we still always just write P, and sulfur exists as S8, again, even though we always just write S. But I thought that was interesting to see. Compound always has the same composition and properties. Again, it's called the law of constant composition. There's 2 types of mixtures, heterogeneous and homogeneous, and I just like to say hetero means different, so it's going to be different throughout. Homogeneous is the same throughout. So if you're looking at some kind of mixture, almost if you can take 2 chunks of it, if they look a little different, the slightest difference is going to be heterogeneous, but if they're exactly the same, it would be homogeneous. So if we look at the difference between a compound or a mixture, compound, one kind of piece. It is a molecule, but it's going to be that same kind of piece all the way through. Where a mixture is going to be more than one of those molecules or atoms together. Compound, it's a chemical change. A mixture is a physical change. And a compound, again, only has one kind of component, where a mixture is going to vary their composition. So if we look at these dots, are you going to classify that as an element, compound, or mixture? Hopefully you chose element. Now let's look at these dots. Element, compound, or mixture. Good. And again, element, compound, or mixture. Good. Mixture as well. So hopefully you saw the difference here. Element, compound, and mixture. See you in class.